Hey everyone, note 6.3 are on primary trig ratios. And the first thing we want to make sure we do is remember Pythagorean theorem. So just a reminder that if you have a right triangle, the side that is across from the right angle is called the hypotenuse. And it's always across from the right angle. And then A and B are called the legs. And those are interchangeable. So whenever we have a right triangle, it always satisfies the equation a squared plus b squared is equal to c squared. And we can isolate some of these to solve, but generally I like to just leave it as a squared plus b squared equals c squared, plug in my numbers, and then isolate. So it says here, solve for the missing sides in the examples below. If necessary, leave as an exact answer. So I don't know this side right here, so I'm going to call this side x. And in a right triangle, the side that is across from the right angle is the hypotenuse. And then this could be a or b. These are interchangeable. So if I do this right here, it's a squared plus b squared equals c squared. When we take a look at what we have here, we know that the a is the x. Again, I could also just put that in for b. It doesn't matter. We know that the b is going to be the 5 and that the c is going to be the 13. Then I'm just going to go ahead and evaluate each one of these. So x squared I can't evaluate, but 5 squared I can. And 5 squared means 5 times 5, which is 25. And then 13 squared is 13 times 13, which is 169. In order to solve for x, I have to get rid of this 25, move it over. I get rid of it by subtracting. So 169 minus 25 is 144. I can square root both sides in order to solve. And don't forget that there are two answers, a positive 12 and a negative 12. But because we are talking about side lengths, the answer here would just be positive 12. All right, and then in our next example, we know that the side that is across from the right angle is the C value. That's what we're trying to find. We know that this is A, and we know that this is B. So when I use Pythagorean theorem, I'm going to say A squared plus B squared equals C squared. I can put in the 11 for the A or for the B. It doesn't matter. I can put in the 12 for the B. I'm just doing this quickly because this should be review. If you need extra help, make sure you come see me during class or at math help, and I'd be happy to help you, okay? 11 squared is 121, 12 squared is 144, and then I get here equals c squared. Now 121 plus 144, I want to add those two numbers together because they're on the same side. It's different than this one because this one we had to move the 25 over because the x squared needs to be isolated. But here the x squared is already isolated, or the c squared is already isolated, so I don't need to get rid of anything. So I'm just going to add these numbers together. I get 165 equals c squared. In order to solve, I need to square root both sides. So c is the square root of 165. I can't square root this evenly, so this is my answer because it asks us to leave this as an exact answer. Okay? All right, so we have a bunch of questions here, but before we do that, let's define a few words that we have here. So I want to define these three words here: opposite, adjacent, and hypotenuse. So if I have a triangle, a right triangle that looks like this right here, and here's my right angle, the hypotenuse is always going to be the side that is across from the right angle, no matter what. So this right here is the hypotenuse. So we're going to say here that it's always the side across from the right angle. We have an opposite side and an adjacent side, and those depend on an angle that we are looking at. So if the angle that I'm looking at is this angle down here, and it's never the right angle that we're looking at, by the way. Okay, the side that is opposite it is just across from it. So this right here is across from it. So this is the opposite side right here. So this is opposite to this orange angle right here. So this is opposite. We'll call this angle A. This is opposite to angle A. Okay. So right here, opposite just means that it is across from the given angle. And then adjacent means that it is next to. Adjacent means next to. So it's next to the given angle. So right here, a given angle is right here. So this is the side that is next to it. But hang on a second. The hypotenuse is also next to it as well. So the adjacent cannot be the hypotenuse. So the adjacent is this side right here. This is adjacent to angle A specifically. Opposite and adjacent will change depending on the angle. Hypotenuse will always be the same side. So the adjacent side is the side that is next to the given angle, but it is not the hypotenuse. So I really suggest that you identify which one's the hypotenuse first before you determine the opposite or the adjacent. So our first question here says to find the side that is adjacent, the length of the side that is adjacent to angle A. So right here, before I do anything at all, I actually think I would rather skip down to this word right here, which is the hypotenuse, because the hypotenuse will never change. And it's always the side that's across from the right angle. So my hypotenuse here would have to be 5. So here's my hypotenuse. Now let's look and see what's going to be adjacent to angle A. So here's angle A, and adjacent means it's next to it, but there are two sides that are next to angle A. However, the 5 is the hypotenuse, which means the only side that is adjacent to angle A is going to be the side that is labeled as 4, because it is next to angle A. Okay, this is our angle. This side is the one that's next to it. It's the one that touches it. Let's actually skip to opposite angle A right here. Since we want to do it based on the same angle, it'll probably be easier. So the side that's opposite angle A, first of all, by process of elimination, has to be 3, because that's the only side that's left. We've already identified the hypotenuse and the adjacent. But also, it's the side that is across from angle A. So this right here would have to be a 3. I'd like you to pause and try to find the answers to the opposite to angle C and adjacent to angle C, and then we'll talk. Okay, so angle C is right here. So opposite to angle C is the side that is across from angle C, which is 4. So what is adjacent to A is opposite to angle C. Okay, and now we need to find the side that is adjacent to angle C. So the side that's adjacent to angle C is the one that's next to angle C that is not the hypotenuse. So that has to be 3. So hopefully you got that this side right here should be a 3. So that brings us to trigonometry. Trigonometry is the branch of mathematics that deals with the relationships between the sides and the angles of triangles and the calculations based on them. And this all comes down to the fact that these triangles are similar triangles because the angles that we're looking at are going to be the same. So let me tell you a little bit more about these similar triangles. Hopefully you understand because we've done an exploration on them to begin with, but let's talk a little bit more about them in a second. But before we do that, we need to define 3 trigonometric ratios. The first ratio that we need to define is called sine, and that is going to be opposite over hypotenuse. And I'll explain to you what this all means very shortly, okay? I want you to understand that this is the real word is sine, but we just take the first 3 letters. We don't pronounce this as sin, it's sine of x, okay? Then we also have cosine. Cosine of x is just going to be written out as cosx. That is the adjacent over the hypotenuse. And this right here is spelled cosine. Okay, and then our last trig ratio that we're going to talk about in this class is the tangent of x, and that is the opposite over the adjacent. And this is written out as tangent. And a little mnemonic device to help you remember this is something called Sohcahtoa. Sometimes you'll see it written out like this. Why is it Sohcahtoa? Because sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. And then tangent is opposite over adjacent. I personally prefer to write it out like this so I can see the actual ratios. So I like to write so, ka, and then toa, just like that. So trigonometry is just basically similar triangles. So this is pretty much just telling us that, like if you see here, opposite over hypotenuse, if I were to turn it on right here, I get 0.68. If I take the opposite, which is this 3.6 that we have here, divided by the hypotenuse, which is this 5.27, I get 0.68. No matter, and notice that the angle is 43 degrees. No matter how big, notice that the opposite and the hypotenuse, those numbers are changing, or how small my triangle is getting, when the angle remains 43 degrees, the ratio remains 0.68. And it only changes when the angle that I'm looking at changes. Notice how the angle I'm looking at is changing, so is the ratio. But if I keep the angle the same and change the size of my triangle, the ratio is always going to be the same. Same thing is true for cosine, adjacent over hypotenuse, I get 0.78. No matter how big or how small my triangle is, the side lengths are changing, but when I divide it, I still get 0.78. Same thing here, when I change the angle, the ratio changes, but once I keep the angle the same, the ratio stays the same. And the same thing is true for adjacent, or for tangent, which is opposite over adjacent. Change the angle, the ratio changes, change the size, and the ratio does not change. All right, so let's apply this now. So the first question says to fill in the following blanks in ratio form. So the first thing I'm going to do is I'm going to fill in this part right here because these are all based on angle x. By the way, x is an angle up here. So let's write down that x is an angle. And it always is sine, cosine, or tangent of an angle. So that's what trig tells us, is that no matter what angle we get, we will know how big the opposite over the hypotenuse is, how big the adjacent over the hypotenuse is. Okay, and we know that from the numbers that we type into our calculators. So if you look right here, it says fill in the following blanks in ratio form. So the first one is sine of angle x. So this is the angle that I'm looking at right here. So based on that, I want to label the adjacent, the opposite, and the hypotenuse, okay? So here, the adjacent is the 9 because that is right next to angle x. But even though 41 is also next to it, that is not the adjacent. That is the hypotenuse because it's across from the right angle. And then 40 is the opposite because it is across from the angle x. So let's write out Sohcahtoa. So sine is always opposite over hypotenuse. So I'm going to take the opposite and the hypotenuse. So this would be 40 over 41. And in ratio form, what that means is just to write it as a fraction. Okay? Cosine of x would be adjacent over hypotenuse. So the adjacent is 9, the hypotenuse is 41. So this would be 9 over 41. And then lastly, tangent is opposite over adjacent. So the opposite is 40, the adjacent is 9, so this would be 40 over 9. Things change though once I switch to a different angle. So this time everything is based on angle Z. So here, this is angle Z. This is still the hypotenuse, so that still checks out. But now this 9 becomes the opposite and this 40 becomes the adjacent. So to find sine, I'm going to do opposite over hypotenuse, and the opposite is now 9, the hypotenuse is still 41, so this would be 9 over 41. Cosine is adjacent over hypotenuse, so it is 40 over 41. So this would be 40 over 41. And then tangent is opposite over adjacent, so it would be 9 over 40. And that's how you do this. All right, in our next example, it says to fill in the following blanks in decimal form. So we're going to do the exact same thing, except we need our answers as decimals. So we're going to type these into our calculators. So I'm just writing out Sohcahtoa for us. Everything here is based on angle B to begin with. So for angle B, we know that this is the hypotenuse, which we actually don't know what the hypotenuse is. So we actually have to calculate the hypotenuse first. So we're going to use a squared plus b squared equals c squared. And since c is the hypotenuse right here, that's what I'm trying to solve for. So I'm going to say 15 squared plus 8 squared equals h squared. Again, hypotenuse is across from the right angle. Okay, so 15 squared is 225, 8 squared is 64. And then if I were to bring this up right here, because I'm out of room, 225 plus 64 is 289. So then I get 17 equals h because I'm going to square root both sides, and I reject the negative answer. So here the hypotenuse is no longer unknown. We can say that the hypotenuse is 17. The side that is labeled as 15 is opposite angle B, and the side that is next to angle B, the adjacent side is is side 8, because the 17 is also adjacent, but it is the hypotenuse. Okay, so sine of B would be opposite over hypotenuse. So here we know the opposite is 15, the hypotenuse is 17, so I'm going to do 15 over 17. But it says to figure out what this is in decimal form. So I'm going to go to my calculator and type in 15 over 17, and it tells us to round to the nearest thousandth, so it'd be 0.882. There's a 3 that comes after the 2, so the 2 stays a 2. We say that this is approximately 0.882. Okay, now for cosine of B, cosine is adjacent over hypotenuse, so I'm going to do adjacent over hypotenuse, 8 over 17. I will type that into my calculator and see what that is approximately. So 8 over 17 gives me approximately 0.47, and then there's a 0, but the 0 is followed by a 5, so that's 0.471. So here we know this is 0.471. And then the tangent of B is opposite over adjacent. So I'm going to do opposite over adjacent, which is 15 over 8. And I end up getting 1.875. I don't need to do any rounding because that is it ends at the hundredths place. So we can say that this is exactly 1.875. Okay, now let's go ahead and do angle C. Everything's going to be based on angle C now. So this is still the hypotenuse, but now the 8 now becomes the opposite because it is across from the angle, and the 15 now becomes adjacent because it is next to the angle. So sine is opposite over hypotenuse, and so we'll do 8 over 17. And we already calculated that number here, so I'm just going to say it's 0.471. Okay, and then cosine of C is adjacent over hypotenuse. So the adjacent is 15, the hypotenuse is 17. So I'm going to do 15 over 17, and we've already calculated that value right here. So this will be 0.882. And then lastly, tangent is opposite over adjacent. So the opposite is 8, the adjacent is 15. So I'm going to do 8 over 15, and I can type that into my calculator. And I get 0.53 repeating, round it to the nearest thousandth, it would be 0.533. So that's how you do it in decimal form. So to find it in decimal form, you still have to do it in ratio form first, and then you just divide it out. Okay? So the next question tells us to find the following rounded to the nearest hundredth. So we're going to figure out how to actually figure out these values. So if you notice here, this says that the sine of 35, the sine of 35, we want to figure out what that's going to be. So I'm going to go straight to my calculator. And the first thing I need to make sure is that my calculator is in degree mode, because there's two different ways that you can measure angles. One is in degrees and then one is in radians. So I don't know if you can notice, but I'm clicking back and forth between degrees and radians on the Desmos calculator. I'll show you in class to make sure that you are in degrees. I'll show you how to make sure that you are in degrees on your calculator in class, but you need to make sure that you are in degrees when we do this right here. And then to get cosine, it's actually down here. We got sine, cosine, tangent, okay? And I want to do sine of 35 degrees. So it has to be in brackets in my calculator. It's going to be sine of 35 degrees. And this says that it is 0.57 because it tells us to round to the nearest hundredth. So here we can say that the sine of 35 degrees is approximately 0.57. What does that mean? That means that no matter how big my triangle is, if I have a 35-degree angle here, the ratio of this side length divided by this side length will always equal 0.57. My triangle could be tiny or massively large, but if I take the opposite and divide it by the hypotenuse, I will still get 0.57. That's what this is saying right here. And knowing that number will help us solve for sides in triangles, and we'll learn about that in the next unit, in the next lesson. All right, so I'm going to show you how to do the next two, and then we will take up the answers for the bottom three next time I see you in class. Okay, so cosine of 68, we're going to type that into our calculator. That is approximately, rounded to the nearest hundredth, 0.37. So here we can say 0.37, and then tangent of 82 degrees. This time I'm going to click on tangent. I'm going to do 82, and that gives me 7.12 because we should end it at that second one, but there's a 5 after it, so that bumps up to a 2. So this would be approximately 7.12. And that's all we have to do for this. Please do the remaining three, and then we will try this out in class. We'll check to see how you did. All right, see ya. Have a good one. Bye.